So you know what homeostasis is?
Yeah, it's just maintaining your, almost like an equilibrium.
Yeah. So we'll start off with an example. Normal body temperature in the human body is about 98.6.
Mm-hmm.
Let's say we have a person outside and he steps outside, it's super hot, it's in the middle of summer, and the first thing that's probably going to change in his body is the body temperature, right? Because the sun's so hot. So this is going to be the variable. It's the one thing that's causing the change in his environment. So the sun's the variable. It's shining down on this guy. He doesn't have any shade to go to. So some things are going to take place. His body's going to start heating up, right?
Mm-hmm.
And so he wants to receive a message to his brain so that they could cause that homeostasis to occur, so that they're in a good spot. So we'll draw this real quick. Set point, that's like the ideal spot. And then what's that little range that they could go in? Do you remember what that's called? Where they fluctuate? Normal range?
Oh, okay.
Does that sound familiar?
I was thinking it was called the set point, but I guess set point's the line.
Yeah, set point's the exact point that they want it.
Okay.
Then range, they have a little space to
Okay.
move around in. So the sun's shining in on this guy. He's going to receive some kind of message that goes to his brain in the spinal cord, the control center.
Okay.
What kind of message is that going to be? Afferent or efferent? Afferent, right? So
he's the control center, or I guess in this situation he would be.
it'd be the medulla oblongata, which is inside the brain. So yeah.
Okay.
So almost always it's going to be the brain and the spinal cord that are the control center. I don't think they'll go too far in depth in
Yeah. Well, they pretty much
anything
control
else.
everything.
But yeah, it controls your body, right? So in very rare circumstances would it be anything else.
Okay.
So what happens is the brain goes, oh, my body's getting too hot, we need to cool down. So we send an efferent. This is how I like to think of it. Efferent starts with the E, right? E represents exit, E for exit. Efferent messages always exit the control center.
Okay.
That makes sense?
Yeah.
Okay, so we got these exiting, and this is going to go throughout the whole body and probably trigger some sweat glands so that it cools off. Cools off the body as it evaporates away. So rather than continually rising and receiving, what kind of feedback would that be if it continually rises?
Positive.
Positive, right? It'd be positive feedback. We want it to go back down and get that negative feedback. So it's going back to set point. And then he'll probably cool down too much, and his body will let it heat up, and it's going to kind of just fluctuate for a little bit. Our body's constantly doing this with all sorts of things. Our blood pH, the temperature, so on and so on. So there's that. So while we're on this example, or do you have any questions before we go on?
See the name of it. So receptor, control center, and effector.
Okay, effector, yeah. So what would be the effector in this situation?
The sweaty.
Yeah, it'd be like the sweat glands, right? So the sweat glands are what cause an effect to change within the body. Because if the sweat glands didn't change anything, he'd still be heating up no matter how many messages are getting sent back and forth, right?
He'd be like the receptor then, and the sun would be the...
So yeah, the receptor, I'm trying to think with this one. Do they give me any new ones? Receptor would probably be, I think what would receive, his nerves would probably feel the temperature change within his body.
Okay.
They were supposed to get that. Yeah, so just the nerves in his body would sense the change, send those up to the brain, and then the efferent signal would go down, and then would go down, and then the effector would cause a change there.
So if this was like switched, and instead of getting really hot, he's getting really cold, you'd still have the same, pretty much he's still, like that's still the control center.
Still,
Effector's
yeah.
what the body's going to do to heat up.
Yeah, so it'd probably be contraction of muscles, increased, his heart would increase the rate it's beating at, so that would be an effector as well. The variable would probably be
What's making
just
it
the temperature
cold?
of the cold weather,
Okay.
right?
Yeah.
And then efferent would still be the same, control center still the same. And then this would be the same except for kind of reverse. He gets cold first and then needs to heat up.
Okay.
Okay? So, let's see if there's a good way to do this. We could do this right now. It's kind of cool. So we're talking about the characteristics of water.
Mm-hmm.
Do you have them memorized yet? Do you know those? We have a rough idea. Okay, so we'll just talk about, we'll go over them right now because it kind of has to do with this and this guy, right? It's still hot out.
Mm-hmm.
And so water's super cool because we have tons of it in our body and it helps our bodies in a whole bunch of weird ways. It almost seems like water breaks a lot of rules.
Mm-hmm.
So one of the characteristics is that it has a high heat capacity. Because of that, like if you took in other liquids and you heated it up to like our body temperature, we'd probably be in big trouble. But it's able to hold heat real well.
Mm-hmm.
So they've done experiments, like just little elementary science school experiments where like you fill up a balloon with water and then you hold a match to it and it doesn't pop the balloon, right?
Mm-hmm.
It's because the heat's automatically absorbed into the water and spread throughout it. So the balloon's never able to heat up enough to pop. Whereas if it was empty, you put a match to it and the balloon pops right away because the air doesn't hold heat as well as water does. So kind of an interesting thing. So we have sun that shines in on us because we were able to hold high heat. Our body's fine. I mean, we'll start sweating, right?
Yeah.
And the reason why we sweat, so we're just going to draw little sweat drops on this guy. This water's holding a good amount of heat, right? So as it comes out of our pores, what's it do? It evaporates off of us, right? That's why we sweat. So it's holding all this heat that's in our bodies, and now it has the capacity to evaporate, right? High heat evaporization. So it's able to rise up, leave our bodies, and cool us down. So
Okay.
kind of interesting
Yeah.
stuff.